Hi everyone, welcome to Home Learning Lab. Today I'm appearing for LeetCode Bi-Weekly contest. It's been quite some time since I appeared for a contest, but let's see how this goes. It has already started. Let me quickly jump to question number 1. Let's open all the questions. So I'll try to solve the questions as fast as I can and try to explain along the way, but let's see. You were given an array nums where each number in the array appears either once or twice. Return the bitwise XOR of all the numbers that appear twice in the array, if or 0 if the number appears twice. Okay. So here this is the bitwise XOR. I mean, the saying either once or twice. So if a number appears twice, then a number's XOR with itself is 0. That property we know. And if a number appears once, then it will stay. So bitwise XOR of all numbers that appear twice in the array. Okay. That's kind of a reverse problem. Let's go to question number 2 and question number 3. We are given an integer array nums and something they have given. So maybe I should just go ahead and try to implement this as quickly as I can. Is there any GitHub or something? One or five maybe. There is 50 numbers, right? I can just do a brute force for the contest. So I want to check if a particular number is repeating. So how exactly do I check that? I'll just check if it's present in front, something like that. Okay. I mean, I'll just go for a purely brute force solution because it doesn't make any sense to think for this particular problem. If I is not equal to j, if nums of I is same as nums of j, then we can have something like a set of integers, and we can do ss dot insert nums of I. Fair enough. There is 0 for int x in ss. Answer XOR equals x, return out. This should be fine. I mean, you can of course optimize it, think a little more, but we can do that during analysis. We did not do that during the contest itself. Anyways, example test cases, I'll try to run. 103, is it? Try to submit. What just happened? Is it solved? Okay. Second question, you are given an integer array nums, an integer array queries, and an integer x. For each queries of I, you need to find the index. Sorry. Okay. Okay, so the first occurrence of x, third occurrence of x in nums array. Is there a fewer than these occurrences? The answer should be -1 for that query. Okay, makes sense. Second occurrence. Okay, so index of the index of the second occurrence. Okay, got it. Makes sense. And this is okay. Got it. Little complexity. I think if I refresh this becomes 1. Okay. Find the number of distinct colors among the balls. This looks like something like or graph kind of problem, maybe I should take a look at this first. Oh, total accepted is 4. There must be some edge cases or something. This has some high submissions. So you're given an how to do this? I mean, 10th query is not allowed. So if x is 1, how much does make sense? So second time it occurs. Can't we just implement it very quickly? I mean, so for any particular x that has been given to us, we will store all the occurrences and map their indices. Yeah, I think this is just implementation, isn't it? I don't think there is any stroke of a genius over here. We just implement map in storage, something like that. Then all I have to do is in canon is nums.size 0. It does that n plus plus. All I have to do is if nums of I is same as x, what I'm going to do is, so storage of, well, what do I want to do? So for every query, I want to map it. So first occurrence, second occurrence, third occurrence. I think a vector will suffice for this. So first, second occurrence. So this is all the instances that I have. So I can just do all dot push back. All dot push back, I think I, the first occurrence. This should make sense. Then all I have to do is, I have to return a vector answer. So for int x in queries, if this x is greater than or equal to, I mean, it's greater than, I guess, yes. If it's greater than all dot size, I mean, all the times we have encountered x, let's not call it x, this is causing confusion, let's call this q. So for whatever occurrence we are seeing in queries vector, if that particular occurrence is more than total number of times we have seen the element, then we can just do answer dot push back -1, else answer dot put back, I mean, if this is q, we can push all of q -1, isn't it? And then return answer. Should work. Let's see. However, just use example discuss and try. 0 -1, 2 -1, I think that was what was expected. Let's see. 0 -1, 2 -1, and then -1. I think that's what we are doing, right? If it is this, if nums of I is barabar x, so just push the next occurrence, the next index. And that just makes sense. I mean, it should work. Let's see. Yeah, it's done. So cool. Let's go to the third question. So second one was also purely implementation. I mean, there is no stroke of genius. How much time is elapsed? Already 10 minutes. Man. You are given an integer limit and a 2D array queries of size n cross 2. You are given an integer limit, okay, and a 2D array queries of size n cross 2. There are limit plus 1 balls, okay. Because after every query we need to do, so something dynamic is happening over here. How many people have submitted so far? Let's just check that. It will give us an idea how many edge cases are there. Okay, there are edge cases definitely. Is this easier? Sometimes hard questions are actually easier than medium questions. It has happened in the history of LeetCode contests. That's fair. Okay, total accepted is still 0. Tough question. We just try to focus on finishing this correctly. Okay, ball X with color Y makes sense. After each query, you need to find the number of distinct colors. Okay, got it. How many distinct colors? Okay, got it. Return an array of result. So what they're saying is, here we have limit 4, so we have 5 balls, and the labels are from 0 to 4, 0 based indexing. And for every query, we'll mark the ball with that particular label with some particular color, and for every query, we will say how many distinct colors are there. So, for example, after query number 0, ball number 1 has color 4. Okay. Similarly, after query number 1, ball number 1 has color 4, ball number 2 has color 5. Fair enough. After query number 2, ball number 1 has color 3, and ball number 2 has color 5. Okay. And after query number 3, ball number 1 has color 3, 2 has 5, and 3 has 4. So there are 3 distinct cases. Just to go over it once again, what that's saying is, yep, that's it. Count distinct. How do we do this? Count distinct. What are the limits? So, okay, this is it. Queries.length is this much. Makes sense. And whatever values you have, it will be 0 or less than equal to limit. How can it be limit? Okay, so we have limit plus 1 balls. Makes sense. 0 based indexing. Works fine. Okay. So after the first query, answer has to be 1, I think. Yes. And then we have to keep a track. So after we run every query, one option is to iterate through all the balls and check what their colors are. But of course, that's not an efficient way at all. So have to optimize. What I'm suggesting is a brute force solution would be something like, each time you color a ball, you iterate through all the balls you have and you check how many distinct are there. But of course, that is not an optimal solution. To do this, so multiple solutions might pop up to people's mind, but there are problems in, like, there can be a lot of side edge cases. So just to appreciate how I think this is a good problem, because so let's say you colored the first ball with some color, let's say 3, then you colored the second ball with 5, third ball with something like 7. So one might be tempted to say that if we haven't seen a color, just add it to the distinct set, and if we have seen a color, then don't add it. But that's of course not a viable solution, because so when will it not be a viable solution? So maybe let's say, what can I say? Yeah, so let's say here I convert it to 4. Then let's say there is ball number 4, which I'm marking as 3. Okay. So after this point, since you are making 1 as 4, your distinct balls colors will be 4, 5, and 7. Here, this should ideally be added, and the total answer should be 4. But if you don't wisely remove 3 from the set, you will say here that I have already seen 3 and you will not increment this to 4. That can be one of the problems. Like, you have to be very efficient when there are color changes. I think that will be a big issue, because if balls are not repeating, balls of same colors are not repeating, I don't think that will be an issue. But once they start to repeat and take on different colors, I think that needs to be handled in this problem wisely. How do we do this? Can we count number of sets, or we can form sets or something like that? Maybe, not sure. Let's take a look at this example and try to see what can be done. So already a lot of people have got this accepted. I don't think it's that difficult also. I think we should be able to do it. Okay, a lot of people have got this accepted, so we should be able to do it. So what we can do is the zeroth ball is this, first ball is this. What is this? If we have seen a color already, we don't need to do anything. But let's say, and if it's a distinct color which you have not seen, of course we will add it to our set. But what should I do if I am changing a color? Okay. How do I handle color changes? That's a pretty technique. I mean, how do I do that? Yeah. What are the colors possible? So colors can be anything. Can be anything. So if a particular color is present, what do we do? I mean, do we have reverse mapping? A particular color is being present this many times, and then when I'm doing an update, I have to remove it or something like that. Well, so current color of something, whatever it is, its counter needs to be reduced. I think there's still implementation, something like that. Let's start implementing and we'll see how it goes. So let's say we have n is number of queries we have, and we have limit number of balls with us. So for every query, we need to do something. Let's create a map which is ball color. Like it maps the ball to the color it has. Then we create a map called int call outer. Like for every color, how many times is it present? Maybe. Okay. So what you can do is now what you can do is for every vector that we have in queries, ball color of p of 0 is p of 1. That's pretty simple. I mean, this is the ball and this is the current color of the ball, so to speak. And call counter of like the color counter of the given color will be increased. What we need to do is if so, whatever was the previous ball color, here we need to do something. If ball color dot find p of 0 not equal to ball color dot n, I mean the given ball had some color, then call counter of ball color of p of 0. So whichever color that ball had, its counter, okay? So ball color of p of 0 had some color. That particular color call counter will be minus, will be reduced. And if call counter of this becomes 0, if this equals 0, well, I think we can just erase it. Is it? how do I find this pointer? I mean, we usually delete with pointers, so we can do auto it is call counter dot find this particular value. Okay, and call counter dot erase. Maybe I think they should be fine. Otherwise, this is what we have, and returning a vector of answers. And to answers, vector will just push back call counter dot size. Does this work? I don't know. I mean, I have just done some implementation without thinking much. So 1, 2, 2, 3. Is it correct? So that is correct. Let's test another example. 1, 2, 2, 3, 1, 2, 2, 3, 4. Yeah, it's correct. Time complexity wise, I mean, we are using a map which is a tree, binary search tree. So we're going through all the queries. If we are able to find a particular thing, that will be logarithmic, doesn't it? Find. So find function, can it be too costly? So if ball corner does find a particular, like if it is present previously, then we'll reduce the counter, and if the counter becomes 0, we'll find where exactly it is present and we'll erase it. Otherwise, we'll just assign the current color and we'll increase the counter. Let's try to submit. I mean, this is still a brute force solution. It might get failure, but it's accepted. I mean, come on. Yeah, so I'll just quickly go over the solutions for questions for the problems number 1, 2, 3 for this particular bi-weekly contest. So all these questions are ridiculously easy, taking into account that it's actually a contest, and I actually took a bit more time than I should have taken. 10 to 15 minutes is enough for the first 3 problems. And so looking at the first problem, of course, there can be optimizations possible, but this is the first possible solution that can be implemented. You can say that nums dot length is just 50, and like it's a very small range to work with. And they are saying something like return the bitwise XOR of all the numbers that appear twice in the array, and every number just appears once or twice. So this is just brute force implementation. I iterated over the array twice in a nested for loop, and I checked that if a number is being repeated, so I am ensuring that by this piece of code, if the indices are not matching and the number is repeated, then I store it in a separate set and I finally take the XOR. So I'm using extra memory here through this set, and time complexity is also poor because I'm using nested for loop. Maybe we could optimize this. So this is the brute force solution. I mean, you just do what has been asked to do. There is no stroke of genius. Maybe if I take the direct XOR, so XORs of numbers when they repeat, if we take XOR, it will just amount to 0. So for example, if I take XOR of 1, 2, 1 and 3, it's same as XOR of 2 and 3. Can we use that? I don't think we can, because if we do that, so somehow we have to track numbers which have appeared just once, right? Even if I took that, even if I did that, so I don't think that's good enough. That's good in any way. I don't think so. We need to track numbers which have just appeared once. Or maybe, yeah, maybe we can optimize this in this fashion. So I have 1, 2, 3, 4. So I'm just giving an optimized approach for this to reduce the time complexity. So here n is 50, less than equal to 50, so it works. So what if n was very large? So maybe there what we could do is, so if n was something of the order 10 to the power 5 or something, for this particular example, we have 1 to 1, right? So you can do something like you take some variable called 10 and you take XOR of all the numbers. So you do the first for loop. So for loop 1 that iterates through all the numbers and takes the XOR of everything. So when you do that, numbers which repeat, those XORs will cancel out, and ultimately you will be left with XORs of numbers which appear just once. So that will be XOR of 2 and 3. So for those of you who don't know, XOR of X in itself is 0. And so if I do 1 XOR 2 XOR 1 XOR 3, 1 XOR 1 will cancel out to be 0, and 0 XOR any number is same, the number itself. X XOR 0 becomes X. Right, because alternatives will light up. So for example, if I had 1 0 1 and 0 0 0, XOR will be the same thing, right? This is alternate, the same, so it will be same as 1 0 1. That's a point. So in the first for loop, I'll take an XOR of everything and be left with XORs of numbers which appeared one time. Then in the second for loop, what can I do? I can have a set called scene or something, scene. And for this particular example, the numbers are small as well. So maybe I can have a finite length vector. I need a map or something just to make sure that, I have seen this particular number. For if the numbers, like the total number of elements possible is very large, let's say the order 5, we can use a set or a map. Again, we have logarithmic search complexity, so that should be fine. So you can have a scene type of a storage, wherein in the second for loop, if we can just mark scene of element as true, something like that. And what we can do is, if we have not seen a particular element previously, so what is it that we can do actually? Okay, so if we have not seen a particular element previously, we can do temp XOR that element. Temp XOR equals that element. And if we have seen, we just ignore. So what that would do is, let's say we encountered 1 for the first time. So initially temp was 2 XOR 3. And when we encountered 1, it's initially not seen. So now temp will become 2 XOR 3 XOR 1. And we'll mark scene of 1 is true. So for scene table, for 1, if this is the value, this becomes true. Then we go to 2. 2 is also not seen. So we'll take temp XOR with 2. 2 XOR 2 will cancel. This will go off. And scene of 2 will become true. Similarly, again we see 1, but 1 is C. So just ignore it. So temp remains as it is. But for 3, again it is not seen. So again 3 goes off and we are left with 1, which is what we want. So why this approach is good is because, we are utilizing this property that X XOR X is 0. How we are doing that is, in the first pass, when we take XOR of everything, elements which appeared twice will vanish. In the second pass, scene of elements which have appeared just once will always be false when they are encountered the first time. So we'll take an XOR. So for example, 2 just appeared once. So its scene of 2 will be false, right? So we'll take the XOR and ultimately 2 will be cancelled from the final answer. Same goes for 3. But for numbers which have repeated, what will happen is, first time you see that those elements, they were not present in temp because they got cancelled in the first for loop. In the second for loop, when you see them for the first time, they will be included in the answer, but you will mark them in the scene array. So when you see them for the second time, you will not be marking them again. And thus, they will be the ones which will survive. I think this approach should work all as well. For this, the time complexity will be, when we are doing 2 for loops, so it might appear like linear complexity, but we are also maintaining this additional data structure, this map, so to speak. And if the total number of elements is very large, or at least, the value of the element is also very large, let's say n can be 10 to the power 9 or something, we have to use a map and we have to search. So for each of the element, we might have to search in our map whether it is present or not and take a decision accordingly. So I think worst case time complexity it will be something like of the order n log n, still better than the quadratic complexity that I implemented for the contest purpose. And space will be, this is the additional space that we are using. This temp variable is fine. This is that is order of 1. So this is the additional space that we are using. That will be order of n. So space complexity is almost same as, I think it is the same as the solution that I implemented for the contest. What I have it done. Yeah, I'm using an additional set. So space complexity is the same, but time complexity is a definite improvement. So two forward, two forward. And I'm also taking some additional constraints like the number of elements is large, the value of elements is too large, and I'm taking all those things into consideration. And even then, we can get it solved in L log time by cleverly applying this property that an element XOR with itself is 0. True to for loop passes. Take an XOR. In the second for loop, if the element is not seen, take the XOR. If it is seen, don't take the XOR. So elements which appear twice will stay in the end. I think that is for problem number 1, the optimal approach for the first problem. Let's look if we can optimize question. Problem number 2. Problem number 2 is, I don't think this problem can be optimized at all. Here, you just need to, store all the occurrences. So if x is 1, we need to know at which indices x is a. So if x is 1, I'll create a vector which will store 0 and 2. And for every query I see, I'll have to check what is the total number of occurrences of x. If that itself is less than the query, then answer is -1. It's not possible. Otherwise, whatever the query number is, I mean, the order of the appearances, I can convert it into a zero-based indexing and return that particular index. I think that has to be done. We have to store in an additional data structure the locations of the given element, the locations of x, at what all indices x is present. I think we have to do that. Otherwise, I think this query function will lead to repeated checks in nums. I think that will be more inefficient. So if I try to save on space, it will become time costly. I'll have to iterate through the nums array again and again. I don't think that is a good thing to do, so to speak. So I think we have to use additional space, and each time x is present, we have to store it somewhere, and we need to do the check. So that's all fairly simple. You use an additional vector, you store all the instances, all the indices instances, and for every query, if the given query is itself more than total number of appearances of the given element, then answer is -1. It's just not possible. Otherwise, convert the appearance order to zero-based indexing and return it. That's it. So here, it's fairly simple. The approach is very straightforward. Just for time and space complexity, we're just doing for loop passes. So for problem number 2, time complexity is big of n. So we are iterating through the array, same as x, we are pushing it. And the same thing, we are going through the queries and we are just retrieving the element. Retrieval is big O of 1 because we are doing index-based retrieval from vector, which is big O of 1. So overall time complexity is big O of n. It's just iteration through the array. Space complexity will be big O of n. That is, let's say we have array of size n and x is present entirely. So it's like x throughout. In that case, our array that we are using to store the positions of appearance of x will have all n elements. So space complexity can also go to n. But I think this needs to be done because if I try to save on space without using an additional space, I'll have to keep on iterating on nums array again and again. I think that will cost our time complexity. I don't know. For now, I think this is the approach that we should go ahead with. This is just brute force implementation. Maybe some more optimizations are possible. Third problem. So third problem was also interesting. That just worked with implementation. So I mean, I just went ahead with a tree-based implementation. We are using map data structure, which is basically binary search trees. So it's just, what can I say? It's kind of tricky to understand what is happening in the problem, but uh, once you get the hang of it, one should be able to understand. So this was the most important part in the problem that I discussed while I was solving the problem, that when a color is repeating, you have to deal with it carefully. You have to remove it from the set and you have to update for the particular ball. So just a little about what I have done here. Let me do this in white or something just for our differentiation of colors. So what I did here was I maintained two maps. One maps the ball and its color, and there is another map which maps color to number of times. Okay. Now each time we're iterating through that x comma y vector, which basically means ball with label x, you mark it with color y. So what we have to check is if this label x is present in the given map. Because if it is present, then it was pointing to some particular color. Whatever color it was pointing to, that particular color's number of times has to be reduced because we are changing it, right? So that will be reduced by 1. And let's say that color's total number of times becomes 0. Then it has to be removed from the map altogether, because if it is kept in the map, it is problematic. I mean, it's not a distinct color anymore. So let me explain that. Let me explain what I have done through this example. I think the direct implementation itself is kind of confusing. So here I'll have, let me call this map 1 and let me call this map 2. So here I'll write map 1. Here I have my map 2. Then map number 1, I have my ball and the corresponding color. And map number 2 has the color and the number of times. I mean, how many times this color has appeared. So for map 1, once I see color number 1, which is map to 3, I'll check is ball number 1 present in the map previously. That's what I'm doing. I'm checking if map of the given ball is not equal to map.10. That's basically a search in the binary search tree of the given map. This is ordered map. These are ordered maps. Ordered maps are hash-based implementations, but sometimes they lead to time limit exceeded because of collisions, as you all know. So it's always a safe choice to go with the tree-based implementations, which are the ordered maps or ordered sets. Just a side note. So here what I'll do is I'll check is 1 present in this mapping. It's not present. So I'll just do 1. I'll map it to 3. And I'll also do color number 3 is present 1 time. I saw it just now. That's it. Now ball number 2 is 5. Isn't present in the map? No. So I'll just add it to the map. And color number 5 is also present 1 time. Similarly, 3, 7 will be added to the map. Color number 7 is present 1 time. And each time I do so, I'll take how many elements are present in this map, because the number of elements present in this map, it will all be distinct colors, right? Because for every color, we are just updating how many times it is present. So the total number of elements in map number 2 will be the total number of distinct colors at any point of time, at any given point of time. So we'll keep on taking the size of map 2 as we process each query, and that will be the total number of distinct colors we have at any given point of time. When we encounter this 1, 4, we'll see that, well, it is already present. So if it is already present, which color is it corresponding to? 3. Go to 3, and since that particular color is being altered or updated, first you make this 0, 3 becomes 0. Then here we will of course do the update. 1 has become 4, and here 4 becomes 1. And additionally, since color number 3 is present 0 times, it needs to be removed, so that total number of distinct still remains 3. Okay, this is very important to understand what just happened here. Is there any undo button? Yeah, there are undo buttons. Let me go through what happened here quickly. It is very crucial what happened here. What happened here was, let me use green for this. When I encounter 1 to 4, I see that 1 already has a color associated with it. When I'm updating a particular ball's color, I need to make sure that the particular color present in the color map also gets updated. So 1 corresponds to 3. 3 is present 1 times. But since the color is being updated, I'll make it 0. I'll reduce the counter by 1. Please note that if it is 1, 3 once again, it doesn't matter, right? So we'll make this mapping to 0 initially, then come back and action to 1 will be mapped to 3, and here 3 will become 1. So that's a safe action that we are doing. But in this particular case, 1 corresponds to 3, 3's frequency becomes 0. Now 1 will correspond to 4, 4's frequency will become 1. And since 3's value becomes 0, we'll have to remove it from the map. And now also total number of distinct is 3, and we'll use 3. So for that particular query also, 3 will be the answer. So this particular part is very important. So if it is already present, you need to update it in the map and you need to delete it. So I've used pointer-based deletion, which are all logarithmic and quite efficient in nature. So that's why I've used ordered sets here, that for every query, if we have the ball present, then we reduce the counter, and if the counter becomes 0, you find where that particular element is present in the tree and you erase it. So that is logarithmic. So this is a logarithmic function, this if condition. And if that is so, you reduce the counter, and within that logarithmic function, we have another logarithmic call to find the particular location and to erase it. And all that we need to do is update the map number 1 and also the current counter map. That's it. So for every query, if I have n number of queries, at most we have find function within it, which is logarithmic, and we have again erase function, find the particular element pointer and erase it, which is also logarithmic. So we are using extra space, ball color, ball counter, something like that. And I think we need to maintain 2 maps for this. So for this particular implementation, space complexity will be big O of n, because we are using 2 additional data structures to store the mappings between balls and colors, and the colors and the number of times they have appeared. So that space complexity, time complexity is each time, like when we are inside the for loop, we are doing a find operation which is logarithmic, and we are doing again a find operation, find the pointer and erase it, which are logarithmic in nature. So it is n times log n into log n. So that will be the type complexity for the solution, which works, which is good enough for the given problem. So that's about problem number C. So problem number 1, we went over an optimization that if we want to reduce time complexity and we assume that elements are large, total number of elements is also huge, then this is how we can go ahead with it and optimize the solution for N log n time complexity, and we go for space complexity. Solution number 2, I think that's the best we can implement. We can't compromise on space, otherwise we'll close out time. Solution number 3 is, it's a bit implementation heavy, to be honest, and the implementation is all that matters for this also, but it's important to see how to implement it. And even then, we have to make sure that if we're using ordered maps, the time complexity is well within the limit based on the given constraint, which it is in our case. So that's all from my end for this particular contest. If anyone has more optimized solutions for any problem in ABC, please feel free to comment below the comment section. This is still early hours. The contest is about to end. So there is a very high possibility that the solutions that I have provided, although they are quick and they work, they are not the most optimal ones. So please feel free to add in the comment section if you find any optimization for any problem. So, and also if you find the solution for problem number D, that would be great as well. That's all from my side. Thank you for watching the video. Happy weekend.